Welcome to video chapter 10, lesson 2, video 3. Today we'll be looking at finding the partial sums of arithmetic sequences. It's an interesting fact that when I have an arithmetic sequence and I add the first and last term together, I get 11 for this case. And now we'll do each of the others like this. That's 11, that's 11, that's 11, that's 11. Notice that you always get the same number. This leads us to an interesting approach to finding the sum of an arithmetic sequence. The sum of an arithmetic sequence can be found by adding the last term and the first term. And then notice that I have half as many of these sums as I did in the sequence. So that means I take the number in the sequence and divide by 2. And we notice that in this case, that gives us a 10 over 2 times 1 plus 10, which is 5 times 11, which is 55, is the sum. That's a lot faster than adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 by noting the patterns that we have in an arithmetic sequence. So this is a very important formula for our use. So we'll write that as Formula 1. The sum of a sequence is equal to n divided by 2 times the first term plus the last term. Now we don't always know the last term because we may have only a few of the beginning terms of a sequence, or we may have the first and the last and a few in between but not know how many are in the list. And so there is another formula. If we substitute for a sub n, we get this. The sum is equal to n over 2 times a sub 1, but a sub n is just a sub 1 plus n minus 1 times the common difference. Adding these two together, we get formula 2. Partial sum is equal to n over 2 times 2 first terms plus n minus 1 times the common difference. And we can use these two formulas to help us find partial sums of various types of arithmetic sequences. Let me do several examples for you. Here's the first example. 3 plus 15 plus 27 plus, we don't know how many, plus 303. And we're going to find the 26th partial sum. So that means, what can I find? Well, I can see here, a sub 1 equals 3. I can look at the increases, and I can see that this is going up 12 each step. So I see the common difference is 12, and I know n equals 26. Now I can find the partial sum using formula number 2, which is 26 over 2 times 2 times the first term, which is 3, plus n minus 1, that's 25, times the common difference, which is 12. This gives us 13 times 6 plus 12 times 25. 12 times 25, I believe, is 300. And so we get 13 times 306, 300, sorry. Yeah, 306. And using multiplication, 306 times 13, 18 and 9, 603, equals 3,979. Check my mathematics. Let's look at another example. Let's find this. Negative 28 plus negative 19 plus negative 10 plus ... plus 242. Here we're supposed to find the sum of the entire sequence. Well, I have the first term, a sub 1 equals negative 28. I have the last term, a sub n equals 242. I can find the common difference. Let's see, when I go from 28 to 19, negative 19, I've gone up 9. So the common difference is 9. But I don't know what n is, and I need to find n. So to find n, I'm going to use the fact that the last term, 242, is equal to the first term, negative 28, plus n minus 1 times the common difference, which is 9. So 242 equals negative 28 plus 9n minus 9. So 242 plus 28 plus 9 equals 9n. And this is 270 plus 9, 279 equals 9n. So n equals 31. So now that I know that I have 31 numbers in the sequence, now I'm ready to find the partial sum, and I'm going to do that using the formula 1, that the sum is equal to n over 2 times the first term plus the last term. So I have 31 over 2 times, and now this is 220. I'll divide by 2 first. So this is 31 times 110. So 110 times 31. The sum is equal to 3410. Always check my arithmetic. I hope that I do them correct, but I am known to make a simple mistake or two, as you are often done on your homework. Now let's look at sigma notation. Suppose I want to find the sum of this one, 3 plus 2n, beginning with 1 and going to 20. So that's going to be n, 20, over 2, times the first term, and I find the first term by plugging 1 into the formula. 3 plus 2 is 5. And I can find the last term by putting 20 into the formula. 3 plus 40 is 43. This then is equal to 10 times 48, which is 480. So here I used formula 1. Let's take a look at another example. This one has a trick in it. Notice that now we're not starting with 1, we're starting with 2. So normally going from 1 to 9 would be a total of 9 steps. But since we're starting with 2, the actual number in the sequence is 8. So I have to use this in the formula. So this will equal 8 times, and now to find the first term, I'll use n as 2, negative 30 minus 12 is negative 42, plus, and now we'll use the last term, negative 15 times 9 is 135. Negative 135 minus 12, which is negative 147. And so this will be 8 times negative 189. 8 times 9 is 72. 8 times 64 plus 7 is 1. 8 times 8 and 7 is 15. So the sum would be negative 15 over 2. The trick is that we had, over 2. So now we have to divide that by 2. Negative 756. Almost made a mistake there. This should give you an opportunity to be able to work the problems that you have in your assignment.